So let's go ahead and do this. I'm going to do this on two different sets. And they're going to seem sort of silly, a little bit sophomoric, but bear with me, and this is so easily extendable to, I'm going to change colors here, to any data set of any size. So here we go. Let's just say, I'm not even going to try to come up with a way to justify this data. Let's say that it's 2, 4, 6, and 8, 10, 12. All right, so we collect data, and this is the data that I get, and we order it because we're looking for quartiles, and we're looking for medians, and we're looking for all that good stuff. All right, so this gets real simple. I'm going to do Q1 is equal to 2. Q1 is equal to 2. Try that again, ding dong. Let's try the min is equal to 2. It's good to see your instructor make mistakes. The min is equal to 2. Now, let's get some freebies here for just a sec. I'm going to do Q1. I don't know what that is. I'm going to do the median. I'm going to do Q3. I don't know what that is. And I'm going to do the max. Now let's grab some freebies. The max in this case is 12. The median, now let's see, how did that work again? It's the physical middle of the data set. So it's going to be a value. It's going to be a value that cuts a 6 data size sample, an n of 6, in half, so it's going to live somewhere between the third and the fourth data value, so it's going to be 7. If I took the average of 6 and 8, I would get 7. Okay, now watch how this works, because this is kind of important, and you'll see what happens when I tack on another data value. Think of the median, no matter where it lives, I'm going to remove it from the data set. So what I've done now is I've cut the data set into halves. And the reason that I do this is I have to find Q1. Now Q1 is really the median of the lower half of the data that's left over. So remember, 7 lives right here. So what I have is these 3 data sets. So the median of these 3 data values would be 4, and that is Q1. Same thing for Q3. The data that's left over to the right of the median or above the median, we just think of it as its own data set, and I find the median of that. So this would be 10. And that would be my 5-number summary. So if I wanted to do my box plot, oh wow, you guys are going to make me draw straight lines again, right? So this is going to be 2, 4, 6, 8, 10, and 12. Ooh, looks like I got a little overambitious in my box plottery. Let me change the colors. I do like changing colors. Sorry, guys. All right. So all I do is I put my min here. Q1 is here, and that's going to start my box. The median is at 7, so I'm going to put that guy right down the middle. Q3 is at 10, and and my max is over there. And I do this. I draw my little box. See how it wants to kind of make everything straight, but it just doesn't work. Now, look at this. Notice that the median is right smack dab in the middle of the box. And these whiskers, like I say, box plots are sometimes referred to as box and whisker plots. These whiskers are the same length. And that means that we have this wonderful symmetry in our data. So just by looking at the box plot, in absence of the data, if I didn't have the data sitting in front of me, I could go, oh, median's in the middle, whiskers are the same length. Guess what? We've got at least approximate symmetry. I don't even know, by looking at the box plot, I don't know that n is equal to 6. Okay? Now, I'm going to show you what happens if n changes. I'm going to make n equals 7 and watch what happens. Okay, so again, I'm going to change here. I'll make it green, and I'm going to make this guy 20. And I think this will help kind of show you. It'll give you an example of what you can mine from a box plot. All right, so same thing. We're going to go min. We're going to go Q1. We're going to go let's go median. Sorry about that. We're going to go median. It's really hard to write on something where you can't see what you're writing. I'm writing on a tablet, and clearly I don't write anything on my tablet, so it's kind of hard to see what's going on. Okay, so you ready? We grab our min is the same, it's 2. Our max is a 20. Now let's look at our median. Now notice, now I've got a sample size of 7. So if I'm going to cut this thing in half, I'm going to find the value that makes it so that half of the values are below that value and half of the values are above that value, then 8 is my median now. Now, let's make sure we all understand why that is. There are 3 data values below 8. there are 3 data values above 8. Now watch what happens to my first quartile and my third quartile. Well, my first quartile is the median of the data below 8, which is 4, same as before, but now Q3 is at 12. See, it pulled that thing over. And let's see what happens when I throw this bad boy on a box and whiskers. Now, I'm not going to mess around this time. Let's go 2, 4, 6, 8. Wait, Ripley, what are you doing? My gracious. Let's try to maintain some semblance of scale. 2, 4, am I going to have enough room? 6, 8, 10, 12, 14, I am, 16, hallelujah, 18, and 20. All right, so here's, this just tells me what my numbers are. Now I know that my min is at 2, so I put this guy right here. I know that my box starts, let's keep it kind of pretty, it starts at 4 because this is always Q1, right? My median is 8, so I think I put 8 right there, didn't I? This is my median, this is my min. Let's see, Q3 was at 12, so this is Q3, and then my max is all the way over here. So watch what happens to my box and whiskers. So it's kind of hard to see because you know what's going on. But look, now I've got this big old whisker over here. By the way, this is my max. I've got this big old whisker over here. So that tells me just by looking at the box that I'm probably going to have a right skew. I'm going to have what appears to be an outlier right way over here at 20. Again, I don't know what the data looks like. I have no idea. Let's assume that we can't see it at all. All I see is a box plot. But because of this really long whisker, that tells me that I'm probably going to have a right skew in my data. It also means that the mean is going to be above 8 because this maximum value is pulling the mean away from the median. Now, the cool thing about a box and whisker graph, really it's the 5-number summary that gives this to us. There is a way to determine an outlier. There's sort of a standardized way to determine an outlier. Excuse me. It's actually really simple, but we need a little bit of terminology first. We need something called an IQR, which is interquartile range. Again, with all this vocab, you might want to throw it on cards, just, you know, like flashcards like you would with any other vocab. And the interquartile range is always just Q3 minus Q1. Now, statistically speaking, the unit standard for an outlier is this. If I take Q3 and I add 1.5 times the IQR, if I get a data value that is greater than this, then this is considered an outlier on the top side. So that would be like this. If I add 1.5 times the IQR and I add it to Q3 and I get a data value that's bigger than whatever that number is, that's an outlier. Similarly, if I take Q1 and I subtract 1.5 times the IQR and I get a value that's less than that, then this is considered an outlier. So let's go through this real quick. I'm going to change my color. I like changing colors. Let's find the IQR first. So I go IQR. Let's determine if this 20 value is indeed an outlier by this new method of calculating. So IQR, first and foremost, is just 12 minus 4. 12 minus 4, which is 8. So if I go 1.5 times 8, what do I get there? That's 12, right? Which implies, let's see, Q3, what was Q3? Q3 was 12, so this implies that 12 plus 1.5 times 12, or excuse me, times 8, which is also 12, is equal to 24. Now, our biggest number is 20. Because 20 is not greater than this, even though it appears as though 20 may be an outlier because it gives us that real long whisker, this is not an outlier. It's not an outlier. It wouldn't be an outlier unless it were greater than 24. All right? Now, let's do it on the other end. If I go, let's see, my IQR is 8, right? So if I were to go Q1, which is 4, minus 12, which is negative 8, now what I need is a value that is less than negative 8 to qualify as an outlier. Well, since my lowest is 2, it's clearly not an outlier, which I think intuition told us as much, okay? So it's not, it wouldn't be an outlier unless it were less than negative 8. And since we don't know what our data is, it's entirely feasible that we could get values that are negative. All right? So that's a really wonderful way to use statistics to be able to determine some stuff without even looking at the data. These distributions and these graphs are really great, and they show up everywhere, and they look intimidating, especially if you don't know what you're looking at, but like 2 laps with them, 2 reps with them, and it's like, I got this. This is not very difficult. All right, but you are going to have to know your vocabulary, or else you're going to run into some trouble, because I'm going to throw out things like interquartile range, percentiles, variance, standard deviation, et cetera, and you're going to have to be pretty fluent in those terms. All right, well, thanks for paying attention. I hope you enjoyed Chapter 3.